Hello, welcome to another edition of Cracking the Cryptic. Happy New Year to you all. I'm not sure exactly when this video will go out yet. I'm recording it on New Year's Day in the evening. Yeah, it might go out today, it might go out tomorrow. But this puzzle on screen, I wanted to do it because last year, 2019, the channel really took off as a result of interest in a Sudoku variant called Sandwich Sudoku. And Christoph Seeliger, the brilliant constructor from Germany, published this puzzle on the German Logic Masters site a couple of days ago. And I've been keeping an eye on it to see the sort of comments it's attracted. And universally, the comments are saying this is a very hard puzzle indeed. So I was thinking, I know what we could do. We could, showcase, me solving this Sandwich Sudoku, make a great video. Well, earlier today, that's exactly what I tried to do. The video, it was over an hour long at the point that I abandoned making it because it was just going absolutely nowhere. And so this puzzle took me 2 hours to solve. Now, in defense of myself, I, as you know, don't allow myself to bifurcate. So I have found a logical way of solving this, but it did take me an inordinately long time. And I wanted to share with you that logic. So what I'm going to do today is a very unusual video for Cracking the Cryptic. We don't do this very often. We pride ourselves on live solving puzzles. This one would just have it would have blown up my computer. It would have taken so much so long to export the video. So I'm going to walk you through this puzzle. If you want to have a go at it before you watch the walkthrough, and I really recommend it, give yourself some time because it's not easy, then click on the link under the video. That'll take you to our software where you can have a go. Now I'll talk you through the rules of Sandwich Sudoku now. I know a number of you will be familiar with this variation. It's a beautiful Sudoku variation. Mark and I released an app on this last year, middle of last year. It's been very popular, and it's because it just makes for such a nice puzzle. And let's use one of these open files to talk about it. So let's imagine this clue outside the grid was an 8. What would this mean? You can see there's a normal Sudoku grid and we have to fill it in normally. Where you have these clues outside the grid, this is telling you something about the numbers that are sandwiched between the 1 and the 9 in this column. So let's imagine we found there was a 1 here and a 9 here in the finished grid. We would then know, because of this 8 clue, that the cells sandwiched between the 1 and the 9 had to sum up to 8. Okay? So that's what these clues outside the grid are telling you. Now, of course, in this variant by Christoph, things are immeasurably more complicated, and that is because Christoph has encoded all of the outside clues. So you've got the same, so wherever you, for example, you see a C in the grid, it's always representing a consistent digit. So if we found that this C was an 8, we would know that this C down here was also an 8. But even knowing that, it's not easy to solve this puzzle. You can see some of the columns and rows have 2-digit clues, and sometimes the second of those digits is not given, which also makes it very tricky. And just to mention what these cells that contain letters inside the grid mean, that means that, let's say we found that B was 3 in the finished solution. This B here is saying this cell needs to contain a 3. So in fact, you could view this as saying there are 9 given digits in the Sudoku, and there are, except we know none of them at the outset because we don't know what digits these obviously decode to. Now what I've done, I've attempted to use the software to give you a bit of an aide-memoire pad at the bottom, so as you fill in or as you deduce what each of these letters, what number they need to be, you can fill those in at the bottom and keep track that way. And with that, I shall now attempt to show you and remember exactly how I went about doing this. Now, there's an easy start, which is that the J, this J here, has got to be 0, and you can see that because we've got A, B, C, D, E, F, G, H and I, which are the only other letters used, all appearing in the grid. Now we know 0 will not appear in the grid, so this square here is a 0. Now in our software you can't enter 0, so I'm going to use grey to indicate 0. So the J is 0, we need to remember that. Now the next thing to note is that there are some clues here that have 2 digits. Now if we look at those, there's an F there, an E and an A. So there are 3 different types of clues that have 2 digits. They either begin with an A, an F or an E. Therefore we know for sure that these, the F, the E and the A, must be the digits 1, 2 and 3. And we know that because the maximum size of a sandwich in a sandwich Sudoku, let's look at it here. If this was a 1 and this was a 9, what would these 7 cells in the middle of the row add up to? Well, they'd add up to 35. And that's because we know the total for the row would be 45 minus 1 minus 9 gives 35. So the maximum we could make those cells be would be 35. So we, in fact, given that we know that there are sort of 3 different digits at the start of these 2-digit numbers, we now know those must be the digits 1, 2 and 3. So far, not terribly difficult. Now the next stage I found quite hard, and what I needed to do was to sort of disambiguate this 1, 2 and 3. You can start by looking at this EB clue and asking whether it can be a 3. Now let's think about this. If E is 3, this square would be a 3. Now B is interesting. B cannot obviously be 1, 2 and 3 because we know that the 1, 2 and 3 are the A, the E and the F. So the minimum B could be would be 4. But you can't make a valid sandwich out of the number 34. So in fact B would be 5. And a sandwich of size 35 means it's the biggest sandwich we can make. So that would force 1s and 9s into the extremities of this column. But this breaks, and the reason it breaks is we've started from the hypothesis that E is 3. But if E is 3, this clue down here is at least 30 in size, and there's simply no way we could put a 1 or a 9 in the middle of the row, because the maximum I could make those 3 digits would be 21 if I put 8, 7 and 6 into them, and 21 is less than 30. So in fact you can never have a 1 or a 9 in the middle of a row or column where the outside clue is 30 or higher. So all of that allows us to deduce that E is not 3. And the next thing we can do, and this is more difficult logic, is look at the F and ask the same question. So let's imagine F is 3. What would that mean? Well, here we have a similar type of logic. The I now would have to be a 5 because the I cannot be a 1, 2 or 3, and we know 34 is not a valid sandwich. So again we get the 1s and the 9s in the extremity there. But now some really beautiful stuff that Christoph's built into the puzzle, or at least I think this is what he intends us to do. If we look at these 2 rows, you can see that FE here and E here, and the important thing to appreciate is that neither of these is a 0. In other words, it's not possible for this square and this square to contain a 1 or a 9. Now if that's the case, we need to have a look at this clue here, which is an FJ. Now we know J is 0, we've hypothesized F is a 3, so this clue is 30 in size, and we can't put the 1 or the 9 in either of those squares. So we therefore know that the 1 and the 9 have to be in these 2 positions. And the reason that we know that is that 30 plus 1 plus 9 is 40. I know the total for the row, or the column, sorry, is 45. So if I've got 2 cells that are outside the sandwich and that have to sum up to 5, I can't move the 1 and the 9 further away. The minimum I could make 2 cells add up to outside the sandwich would be 5 using the numbers 2 and 3. So Still not quite there. This still looks like it might work, except look at this clue. Again, remember, we started this from the hypothesis that f is 3, so this clue is at least 30, but we have the 1 and the 9 here. So the furthest I could put the other 1 and 9 would be in that square. So now we've got, let's say I say this is the minimum it could be, which would be 30, plus 1, plus 9, that's 40, plus 5 is 45, and I've still got to put another number into this square. So this row is broken. And this allows us to deduce, not simple, this probably took me 5 minutes into the solve to spot this. So not simple, but not monstrously difficult. Certainly not as difficult as some of the stuff we're going to come on to. So this is not 3 anymore, and that means the A is 3. And now we can do some work with this AE clue, because we know this is 31 or 32 now. So can we put a 1 in the middle of the row? Obviously not. If we make this a 1 and this has to be 31 or 32, we simply cannot have enough room in the sandwich before we get to the 9 at the edge. The maximum I could make those cells equal to would be 21. Sorry, there's a bit of noise outside at the moment. So what that means is this is the 2, this is the 1. We can write in 3, 2, 1 at the bottom. We know this is a 30, we now know because the 2 is here that this in fact is a 32 clue, which means this must be the 9. 32 in the sandwich, plus 1 plus 9 is 42. This square outside the sandwich therefore has to be a 3 to complete the row. And at this point what I did was I started to label the cells in the grid that couldn't contain 1s and 9s. So this is very, very good practice for sandwich Sudoku. Always important, especially on difficult puzzles. So green will indicate that a cell cannot contain a 1 or a 9. Now we've got a C in this column, so we don't know what C is yet, but obviously that C cannot be 0. So these two squares cannot be 1s and 9s. Here we've got an FI clue. Now F is 1, so this clue is at least equal to 14, and therefore we can also highlight those two squares. Next we could look at the EB clue, for example. Now here we know E is at least equal to 20, B is at least equal to 4, so this clue is at least 24. So let's look at this square. Could this be a 1 or a 9? Now we know this is at least 24, so the furthest away I could put the 9 would be here, and I'd have 4 cells to make up 24 or more. But the problem is that this 2 is not high enough. Even if I make these 3 cells as big as I can with 8, 7 and 6, that's only 21 plus 2 is 23. That's the maximum I can make those 4 cells. In other words, this square here cannot be a 1, and neither can this one. So these 2 squares are also green. Now what did I do next? I think I looked at this clue, because this clue is FJ, which we now know is actually equal to 10. Now the key point to realise about the 10 is if we look at this box and ask ourselves the question, what happens if there's no 9 in any of those 3 squares? Does the puzzle break? And the answer is yes, it does, and it's rather nice to notice this. So if this is the configuration, so if those squares are green, how would we make this 10 clue work? We couldn't have that arrangement for the 1s and 9s because we couldn't make this cell wouldn't be big enough to equal 10. So the only way of making 10 if these 3 squares are all green is with a 1 or a 9 here and a 1 or a 9 there. Obviously if we go to 4 cells in the sandwich, 2 plus 3 plus 4 plus 5 equals 14, so that's not going to work. So we'd have to have this arrangement. But this is a problem because 3 cells adding up to 10 without using a 1, can't use the 1 because the 1's making up the sandwich, means these 3 cells have to be 2, 3 and 5. And that would lead to a repeated 3. So, what that means, rather interestingly, is that neither, let's go back to it, we were in this situation, there must be a 9 in one of these 2 squares. Now the corollary of there being a 9 in one of these 2 squares is that there is nothing, there's no 1 or 9 in those 2 squares. And we have to be a little bit careful here because the h could still equal 9. So it's still possible that there could be a 1, 9 here and a 1, 9 here. What else could we know? Well, we could note this, that I here can't be 9, because if I is 9, this total here is 19, but we can't make these 2 squares equal 19, so this is also green. And what else could we do here? 9. Trying to remember what I did next. Let me just try and remember. Yeah, I think what I did was I looked at the H clue. So the H clue here, we now this square and this square. Yeah, this is right. This square and this square can't be 1s and 9s, because if they're 1s and 9s, how do we make this work? Where can I put, if this is a 1, where can I put the 9? It would have to be right down here, and this sum would be too big. So this square and this square are not in. And now this was absolutely gorgeous, this next step. This took me, I guess, 40 minutes to find this next step. Okay, so this is something I'm just going to tell you, and this square here, let's ask the question, can this be a 1 or a 9? And the answer is that it can't be, because look what happens if we try and put a 1 or a 9 into this square. How do we fulfill this H clue? Well, the answer is we obviously can't have the 9 right up there, so this square would have to be a 9. But now look, this sandwich total here is H, so we're going to put in whatever H represents into that square. But look, H is already in the row. We don't know what it is yet, but we know it's in that square. So we cannot have this sandwich being in this square exactly, because it will clash with whatever we put in that square. So isn't that absolutely beautiful? I love that. I mean, you know, it's worth going through the puzzle just to appreciate that bit of logic. That means this square is green. And now we have an interesting arrangement down this column. Let's have a look at this. Is it possible this square is not a 1 or a 9? And clearly it isn't. If we make this square green, the 1s and the 9s would have to be in those 2 positions. And 1, 2, 3, 4, 5, a 5-cell sandwich must be 20 at least, so it definitely can't be a single digit. In other words, this square now is a 1 or a 9. And that took me ages to find. Right, now let's carry on with this now. So now we've got the E clue here. Now we know this E clue is a 2 and then another digit, so it's at least 20. So we know it must be at least 3 cells in the sandwich, so you can extend that a little bit. And now we can use this C, because let's ask the question, can this be the 9 now? And the answer is no, because if this is a 9, we now know this square would be a 1. And now how does this H clue work? We can't put a 1 or a 9 in this square because we've already got the 1 and the 9 in this box. So this square is green, so this square would have to be the 9. Now the only way of making 3 digits into a valid single digit sum would be if these 3 cells added up to 9 and we make them 2, 3 and 4. But if this is 2, 3 and 4, that implies H equals 9, and we started the logic chain by assuming C equals 9. So we can't have both C and H equaling 9. So what that means is that this is not, so C is also not 9. So we're starting to eat through some of the options here in terms of which of these other letters is the 9. We're just left with B, G and H now, so let's label that up, and that'll help me hopefully to focus in on what we need to know. Now C not being 9 is interesting because of this column. Now C is not 9, it's a maximum of 8, and the maximum size of the sandwich therefore is 2 cells. So looking at the 9 we've already got placed, I could have a 1 in this square, but I couldn't have a 1 in that square, and I couldn't have a 1 in this square. So both of these yellow squares must be green. And immediately, this part of the puzzle wasn't too difficult for me. I immediately honed in on the E here. You can see that this clue is a 2 and then possibly a 0. I guess that's the minimum it could be. But now I can rule out this square from being a 1 or a 9, because I know I'll need at least a 3-cell sandwich to make 20. So if I have this as a 1 or a 9, I just don't have enough room. 1, 2, 3. I need to be able to put a 1 or a 9 in the extremity, and I can't. So this square becomes green. And now, the interesting thing about this square becoming green is the way it impacts on the EB clue. And now it's interesting to think about how this being green impacts on this EB clue. The first and obvious point is that this square can no longer be a 1 or a 9, and that's because we know, looking at the value here, that this is at least equal to 24, and therefore, because of this 2, as we've gone through already, I need at least 5 cells for the sandwich, and 5 cells would mean I would need to put the 1 or the 9 here if this was a 1 or a 9, and I can't. But the interesting thing now as well is this square. Can this be a 9? And if this is a 9, let's look at this again just to talk it through. If this is a 9, what does this mean? Well, it means that this clue for column 5 now becomes a 29 column. Now, because this is green, that would place a 1 into this square, and that is that's just not possible. And even if you could somehow have a 1 there, which you can't, that would mean the outies would have to sum to 6, which would mean that they would have to be 2 and 4, and we've already got a 2 in the column. So this square is also not a 9. Now let's look at this. I mean, the first thing that shows us is that this square must be a 1 or a 9. And that means these 4 squares can be made green, because we know that this clue is in fact exactly equal to 12, because it's F then E, and we know the values of those. Now, what did I do next? I think I noticed that, well, yes, I mean, one of the things we can say now with certainty is that because B can't be a 9, the only 2 options for 9 are G and H. So let's look at that and see if we can deduce anything from those possibilities. Now, if G is a 9, we know this clue here is at least equal to 10. So where would the 1 have to go? It couldn't go in either of those 2 squares. It couldn't go in this square because this can't be a 1. So it would have to, all of these 3 squares would be green. If, on the other hand, this was the 9 here, then because again this is at least a 2-cell sandwich, these 2 squares again couldn't be in couldn't be a 1 or a 9. So you'll have noticed in both situations these 2 squares are not in. Now, using the J clue in column 3, which is 0, this square is also out. And I can't remember if I was able to go much further than this without this next piece of logic I'm going to talk about. This took me again probably 30 minutes to find this next piece of cunning that Christoph has built into the puzzle, and I think it's deliberate. I'm not certain about that. Christoph often comments on the video, so he may be able to tell us. But I spent so long trying to find something logical that when I did, I'm sort of the view that this was what I was meant to find. And the thing you need to note is this G and this C clue. Now, unfortunately, one of these could still be a 9. The G could still be a 9, but the important thing to see is that they're both single-digit clues. And we know here that there is definitely a 9 in one of those two positions. So let's think about what this means. Now, the first thing we can note is that even if there is a 9, even if G is 9, it's not possible for this to be a 3-cell clue, because if this is a 9 here and this is a 3-cell clue or a 3-cell sandwich, then the 1 would have to go here, but these 3 squares would be 2, 3 and 4, and that would repeat the 2. So that's not possible. So whether this is a 9 or whether this is a 9, whichever one is true, the neighbouring cell can't be a 1 or a 9 then, and this square or this square would have to be the 1. So whichever one of these is a 9, the 1 will be 2 cells away from it. So we know there is a 1 in exactly one of those two positions. That's difficult enough to see. But watch this next step. This is really clever. The next thing to think about is the implication of this. Let's just assume this is a 9 and this is a 1 for the sake of exposition. What's the effect of that? And then we can do, because this is sort of symmetrical logic, we can just do the opposite. We can see because of the 1s here, we lock a 1 into one of those squares. And now, this can't be a 9 now, obviously, because we've locked all of this is fixed. So the question is, what happens in this row, if you like? Is it possible this square, in fact, what's the best way of doing this? Yeah, is it possible this square is the 1? If this square is a 1, how do we make this G clue work? Well, this square would have to be green, and this square would have to be a 9. So far, so good, you might say. This looks absolutely fine. And it does until you start to think about this a bit harder. Because what we've got now in this central block, believe it or not, is 2 sandwiches. We've got the G sandwich and the C sandwich. But more importantly, we've also already got a 1 and a 2 in the block. So the minimum I could make these 2 squares would be 3 and 4. If I made these 3 and 4, the minimum I could make these 2 squares would be 5 and 6. So what have I got now? I've got 3 plus 4 plus 5 plus 6 is 18. That's the absolute minimum I can make these yellow squares. 18. But how can I make the G and the C add up to 18? I can make one of them a 9 clue, but I can't make the other a 9 clue as well. The maximum I could make these 2 squares add up to, or these 2 sums add up to, would be 17 with a 9 and an 8. So this is broken. And I mean, it's quite gorgeous. It's quite a gorgeous setup, this. And the lovely thing I think about it is that if we go back to this point here, you can see that if we reverse the logic and we just start up here with a 9 and a 1, it works in absolutely the same way. That's going to force a 1 into one of these 2 squares, and again there is simply no way this one can be a 1, because if it is, that's a 9, and we get the same logic, just symmetrically deposed into the rows. So what does all this mean? Well, it means two things, both of which are important. The first thing it means is that neither of these two squares can possibly contain a 1. So we need to rule those out. We know the 1 is in one of those two positions. Now the second thing we need to note is that given that the 1 is in one of these two positions, it's not possible to go from this 1 to this square as a 9. It's not possible to go from this square to this square as a 9. So the 9 that accompanies the 1s that we're going to have to put in either this square or this square must be in those two positions. So these two squares in fact are a 1-9 pair, and that means we can fill in these two squares as green as well. Now, as I say, that was not a simple process for me to come up with, but I'm fairly sure it's what Christoph intended. And hats off to him. I mean, what a stunning idea to incorporate into a puzzle, let alone to incorporate it at this stage of the soul. I mean, it's not like he set this up at the beginning. This is really, really dense stuff. Now, what can we do from this situation? Well, you can see we've now got quite a lot we can do in column 4 there in terms of and now we can look at this clue, I guess, this E clue. This is a 20 clue at least, so you can see this square simply has to be a 1 or a 9. We can't fit a 20 sum into those two squares. So this is a 1 or a 9 here. Now, given that we know one of those is a 1, we in fact know this is a 9. Those two squares must therefore be out. These squares must be out. Let's have a quick look further at this, see if we can... This is a 1 and something, we don't know what. Sorry, I'm just trying to spot the next step efficiently. I'm doing a bad job of it. Yeah, the J clue, that's going to be our next port of call, isn't it? J clue it's a 0, so they must be adjacent, so it's these two squares must be the 1 and the 9. That rules out those two positions. This 9 here had an interesting effect in terms of working out which of this G and the H is a 9. Now this square is green, it cannot be the 9, so we're able to remove that as an option. The H, after all this work, becomes the 9, and we're able to place it in the grid. That means that one up there is a 1. Now let's just... We know that this is at least a 2-cell sandwich because it begins with a 1 here, so those two squares are out. That forces this square to be a 1, look. That means this square is not a 1 or a 9. This square isn't a 1 or a 9. Now there's a 1 in one of those two squares. In this block, there's only one place left for the 9. It must be here. This means this is the 1, this is a 9. That must be a 1. It's the only option for the row. This is a green cell. 1, must be a 1 in one of those two positions. A 9 in one of these two squares. But we know H is 9 now. So that's important because that means this square can't be a 9, because that would mean this square also had to be a 9, and that's not possible. So this is the 9. The H is a 9 sum, so this must be a 9 here, and in fact those two squares therefore must be 2 and 4 to make this sum work, 2, 3 and 4. 9 here, 9, what do we do next? I think... this is a 10 clue. Oh yes, that's right. Now this is a 10 clue. So this square can't actually be a 9. And the reason, let's look at this. If this is a 9, the 1 is either here or here. Well, if it's here, the 10 clue would break because it would have 4 cells in the sandwich, and that's too many. If it's here, how do I make these two squares add up to 10? I can't use 1, 9. I can't use 2, 8. I can't use 3, 7. And I can't use 4, 6. So everything is ruled out. It's quite another incredible piece of logic embedded in the puzzle. So this becomes a 9. Therefore, this can't be the 1. This must be the 1. And finally, I think we're there in terms of, I think, I'm not actually certain, but I think we're there in terms of working out the 1s and the 9s. It must be in this order, and I think, let's just tidy it up. That is the finished disposition of 1s and 9s. Only took me 35 minutes to explain it. So what can we do from here? I have to say that the sandwich part of it wasn't easy either, but it was nothing like as hard as what we've just done. So I'm hoping that it won't take me too long to finish off the video. We've got an EB clue here, but we know that there's only 1 cell outside the sandwich, so that means the B has to be reasonably large. In fact, let's look at that. If the B was 6, then this would be a 26 clue. 26 would be the sum of those cells. Plus 1 plus 9 is 36. That would force this square to be a 9, which is not obviously possible. So we know that this square is higher than a 6. So it must be 7 or 8. But we know that the H clue here is a 9, because we know that the H is 9. So these two squares have to add up to 9. So you can see this can't be 8 actually, as that would force a 1 into that square. So this is 7, this is 2, and that gives us another digit. 2's here, look a 2 down there. Now this, yes, okay. So look, C here is a 2-digit sum, but it can't use a 1 or a 2. So we know it can't be as low as 6, for example, because if it's 6, this would have to be 2, 4, and that's ruled out. So C is now 7 or 8, but B is 7. We've worked that out. So in fact, C is 8, and that might be important. That means this sum here must be 3 and 5, because it can't be 1, 7, and it can't be 2, 6. And we've got C in column 1 as well. And now if we look at, again, we've got a 2-digit sum. We can't use 3, 5, or there'll be 3 3 5s in the row. We can't use 1, 7, so these two squares have got to be 2 and 6. 5. We can place the 8 into this square because we know that C equals 8. And now I think we can look at I as well. What are the options left? We've got 4, 5 and 6 as the unresolved digits. So this square is a 4, 5 or 6, and these two squares are 4, 5 and 6. And in fact, because G is the sum between this 1 and 9, that square must be a 4, 5 or 6 as well. But let's have a look at I here, because I think we can rule out 4 and 5. If we put a 4 in here, the FI clue becomes 14, which means these two squares, combining with the 8, these two squares would have to be a 2 and a 4, and they can't be, because we can't put a 2 or a 4 into this square because there's already a 2 and a 4 in the block. So this cannot be 4. So let's remove 4. What does that do? Just removes 4 from here, I guess. Let's try 5. If this is 5, this is 15. These two have to add up to 7 without using 1, 6. So it's either going to be 2, 5 or 3, 4, where you can see 3, 4 is impossible because we can't put that in there. If we try 2, 5, that's impossible because I started this by assuming this was a 5 in order to give the 15 clue. So this, in fact, I is equal to 6. And these two squares have to be equal to 7 now without using 2, 6 or 1, 7. So these two are 3 and 5, and that must be in that order. So 3 into one of those squares, by straightforward Sudoku for once. Not said that much during this solving process. That can't be a 5. Just looking at the 5 we've just placed here. And in fact, G can't be a 6 because we know I is a 6, so this becomes a 4. Which means that's a 4. And that means that D is a 5. Wow. Okay, so D is 5. G is 4. Let's just see if we can get any other simple digits. You can see that's this 4 is pointing at this 2-4 option, so that resolves that. And see what else we can do. 8 here means one of these two squares must be an 8. And 6 here means another. There also must be a 6 into these two squares. This square, therefore, is a 7. 8 must be an 8 in one of these two squares, and a 6 in one of those two squares. And what next? So H we've done. Yes, this is a 12 sum, look, in those two squares. So there's no way we can put a 3 in here because that would imply that square's got to be equal to a 9. So the 3 is in fact in that square. 6, 3, 4, 5. So what we could probably do with is marking off some of these when we've used them. This has to either be 4, 8 or 5, 7. That means the 8 is either in this, so this is 8 or 5. This is 4 or 7. E clue here, can't remember what to do with that. 5 here. See, these three squares now, look, have got to be 2, 6 and 8. Let's label that up, see if that helps. These two squares have got to be 2 and 4. FJ is a 10. This total is 10, so we need to put 2 cells adding up to 10 here without using 1, 9, 2, 8 or 4, 6. These two have to be 3 and 7. That locks a 7 into one of those squares, makes these two squares a 6 and a 7. Means this one can't be a 7, so that's got to be a 4, which makes that one an 8. This 7 resolves the 7 and the 6 there, look. Should have spotted that before. I think that was staring at me in the face. These squares here have got to be 2 and 5, and that's resolvable. 2, 5. 7. This is a 5, 8 pair at the bottom. These squares have got to be 4, 5 and 6. These two have got to be 7 and 8. This square's got to be a 4 now, because of the 4 there and straightforward Sudoku rules. And this is 2, 5 and 6. Whoopsie. 2, 5 and 6. That one can't be a 5. And okay, now let's see what more we can do. We've got 2, 6 already in this column, so in fact that one is a 5. So we still need 3, 7 and 8 into these open squares. Ah, 3's here, look. So that square's the only place a 3 can go. That means that one down there is not a 3. 2, 3. These 3 squares here have got to be 6, 7 and 8. So this must be a 7. It's the only place a 7 can go in the row. And this square is a 6 or an 8. And the cunning thing, I think, if I remember rightly, actually, this being 27 plus 10 is 37, that's got to be an 8. That resolves the 8 and the 5 over that side. Look, that resolves that 7 as well. I think what I need to do around now is to use the... yeah, if we look at this column, look, this square here can be a 2, 6 or an 8. Now we know that the sandwich total here is a 2-digit number beginning with a 1. So let's look at down here. We've already got 9. So if neither of these is a 2, we'd have 9 plus 6 plus 8. Well, that's 23. So that's not possible. One of these must be a 2. Now, if one of these is a 2, that must be a 6. And this becomes a 2-8 pair. So what next? Those are a 6-8 pair. 2s. You can see the 2 here rules out a 2 from those squares. So we know there's a 2 in one of those two positions. Therefore, we can resolve the 4 and the 2 over on the right hand side. The 4 here means there's a 4 locked into one of those squares in this box. That marries up with the 4s in the central box, so this square must be a 4 in the top box. 2, 5, 7 here. This F clue, F is a 1, isn't it? So the 2 resolves that one as well, so that might help in terms of learning how this F clue works. We need these 3 squares to add up to a 2-digit number beginning with a 1. And what have we got left to put in the row? We've got 3, 5 and 7, have we? So this is a 5 or a 7. This is 3, 5 or 7. Oh, come on. So if actually, that all looks like it might work. 8 here means that's a 6, though. That resolves a 6 and the 8 at the top. These 2 squares have got to be, is that 4 and 8, which is now resolvable. That's 8, that's 4. 4, 4, 4, 4. This is a 4 down here. These 2 squares have got to be 3 and 6. Not quite resolvable yet. This E clue, this is a 20 clue. We don't know. Yeah, this works, doesn't it? 9 and 1 here, so we've already got 11. So if I make this square of 5, no, if I make this square of 5, I'd get 5 plus 3 plus 4 plus 7. That's only 19. That's not enough. This must be 20 at least. So this is a 6, that's a 5, that's a 3, that's a 5, that's a 3. Now that should be, what's that going to be, a 5. Now I think that means this one's a 5. This square should be fillable. It's going to be a 7, is it? 2, 6, 8 here. That must be 7, that's a 7, that's a 3. This is a 6, and that might, I think, be the final piece of logic needed. So, a very unusual edition of Cracking the Cryptic, and I have to say, you know, the reason I wanted to do this is I think there's enough interesting stuff in that puzzle that it merits one of the longest videos we've ever made. So much original thinking, so much cunning on behalf of the setter, and so much to admire from me as a solver, even though I was utterly defeated by this. As I say, 2 hours to solve it, but I hope you enjoyed it. Do let me know in the comments whether you enjoyed this. I don't think it's something we'll do that often, But if you did enjoy it, I'll certainly bear that in mind in terms of future content. Thanks for watching, and again, a very happy new year to you all.